Hi boys and girls. Today's video covers the beginning of Lesson 1.5 Scientific Notation. I'm not going to completely cover 1.5, but I'm going to cover the basics of writing numbers in scientific notation and taking them out of scientific notation. So one thing that's going to be a common thread through this is anytime you have a positive exponent on your scientific notation, you have a number that is very large. Anytime you have a negative exponent on your scientific notation, you have a number that is very small. I'll say that more than once. Okay, scientific notation is a way of expressing a number as the product of a factor and an integer power of 10. When the number is positive, the factor must be greater than or equal to 1 and less than 10. Proper scientific notation, there will be one integer to the left of the decimal. You can have nothing to the right of the decimal, or you can have 1, 2, or more numbers to the right of the decimal, but there will always only be one number to the left of the decimal. This would indicate a very large number. This one indicates a very small number. All right, circle to determine whether each number is written in scientific notation. All right. Well, in order to be in scientific notation, there can only be one number to the left of the decimal. This number is not in scientific notation because there are two numbers to the left of the decimal. This number is written in scientific notation. There's one number to the left of the decimal, and it's okay to have 2, 3, 4 numbers after the decimal. This is in scientific notation. This one is also in scientific notation. There's one number to the left of the decimal. All right, so that's it, yes. And then this one is not in scientific notation because the number to the left of the decimal has to be between 1 and 9. It cannot be 0. So this one is no. It has to be between 1 and 9. All right. Standard form is when we write a number without scientific notation. Standard form is when we just write a regular old number, okay? So there are two methods. I'm not really crazy about their method one. They want you to write the power as a product. Well, 10 to the fourth is 10 times 10 times 10 times 10. So they're saying if you put this in a calculator, 5.34 times 10 times 10 times 10 times 10 equals, I'm assuming they want 1,000 here. No, 1, 2, 3, 4, be 10,000. And then they get the answer 53,400, right? I am a fan of the move the decimal point method, which I think most of you probably are also. When we move the decimal point, if we're talking about a big number, we're going to move the decimal to the right. If we move it to the left, it's because we're talking about a small number, okay? So here, this 4 says move the decimal 4 places to the right. It started here, right at the after the 5, and we moved it 1, 2, 3, 4 places after the decimal. So let's see, in this case, 4. And so the answer is 53,400. So here's our check. This says move the decimal 5 places to the right. Positive is to the right. So if we started with 9.931 and we move 5 places right, we would go 1, 2, 3, 4, 5. Always fill in dippies with zeros. I call these dippies. All right. Then you rewrite the number 9931 with 2 zeros, and then you can go back and put your comma in. 993,100. Example number 2. Write numbers in standard form, okay? So here they're giving us scientific notation again, but this time we have a negative exponent. Negative exponent means move the decimal to the left. They want you to do, this is their method 1 where you do it as a multiplication, but they want you to do this with fractions, and I don't think any of you want to go there. So let's just go down here to the -3 means move the decimal 3 places to the left. So if I start with 3.27 and I move the decimal 1, 2, 3 places to the left, fill in dippies with 0, I get 0.00327. And that's obviously what they got to. Over here for our check, they want you to write this number in standard form. This -4 says you're going to move the decimal 4 places left. So right now it's right there between the 6 and the 0. I'm going to move it 4 places left, 1, 2, 3, 4, and fill in dippies with zeros. So my standard form is 0.000602. Now you can, the 0 to the left of the decimal here, that's optional. You can use it if you like. I think if you use very small decimals, it's helpful to have it, but I use big bold decimals, so I don't really need a 0 over there. That's totally optional. Okay, when you divide a number by 10, the decimal point moves 1 place to the left. Dividing by 10 is the same as multiplying by 10 to the -1. So when you multiply a number by 10 to the -3, the decimal point moves 3 places left, which we've already seen. The exponent on the power of 10 indicates the number of places, in this case 3. A negative sign on the exponent indicates the direction to the left. Okay. So this says move the decimal 4 places to the left, 6.02. We're going to go 1, 2, 3, 4. My dippies are so bad, sorry. Fill in dippies with zeros, and we get 0.000602. Again, the 0 over here is optional. Okay, now they're going to talk a lot about calculators, and in this interesting situation that we find ourselves in, I can't be sure what kind of calculator you're using. The thing I want you to come away with here is if a calculator gives you a result that looks like this here, all right, this means 2.5 times 10 to the -12, okay? This means 8 times 10 to the 11th, okay? That E is your way of telling you, okay, this is the number in front to the left of the decimal, and this is the exponent on the 10, okay? That's what that tells you. So furthermore, on the calculator, if we get the result 4e -7, that means 4 times 10 to the -7 power. That would be how you would write it. Now to write this in standard form means not scientific notation, we would move the decimal point 7 places to the left because it's a small number, it's a negative exponent. And so then they move it from here 7 places left, and that's standard form. Okay. Here's the check. The calculator screen shows the diameter of a grain of sand in inches. Which numbers represent the numbers shown on the calculator screen? This would be 2.4 times 10 to the -3. All right. Well, which one says 2.4 times 10 to the -3? That one. Now, what about these other ones? Do any of these other ones, are any of these equal to this? Well, what would be the standard form on this one? If I move this 3 places to the left, I would have 2, 4. It started here. I went 1, 2, 3 places to the left. Do you see this number over here? This one. It's got that optional 0 that I don't usually write, but it's an optional 0. But it has 2 zeros between the decimal and the 24. So that's a correct solution also. Those are the only 2 correct solutions for this one. Write numbers in scientific notation. So if we're going to give you a big number and ask you to change it to scientific notation, what you have to do is move the decimal so that there is one non-zero number to the left of the decimal. All right. If you have very small numbers, we're talking fractions, numbers that fall between 0 and 1, your exponent will be negative. If we have large numbers bigger than 10, your exponent will be positive. So they're giving you the number 3,725,000, and they want you to write this in scientific notation. Well, when we have a whole number, the decimal is not usually written, but it's right here at the end of the number, okay? So we need to move it until it's right here, all right? Because we want one number to the left of the decimal. Well, we have to ask ourselves, how many times did we move it? From here, it went 1, 2, 3, 4, 5, 6 places. Okay, so we're going to have 10, and it's a positive 6 because it's a big number, right? So which expression represents that one in scientific notation? The original decimal is here. To get it to be here, how many places do we move it? 1, 2, 3, 4, 5, 6, 7, 8, 9 places. And it's a big number, so it's a positive 9. So A is the correct solution. This is super fun, right? Okay, write numbers in scientific notation. Here's some practice with a very small number. Now we know the difference here is the exponent will be negative because this is a very small decimal. But how many places do we have to move it? We want one number to the left of the decimal, so we want it to land here. We move it 1, 2, 3, 4 places. Okay, so this is going to be times 10 to the negative 4. Very small number, the exponent's negative. I'm not doing that fraction thing, that's awful. So which expression represents this number in scientific notation? Well, if we're starting with this number here, 5, 2, 4, in order to put this in scientific notation, we need the decimal to be here, so there's one non-zero number to the left. So we want our end result to be 5.24 times 10. Now, is this more than or less than 1? It's less than 1, so this will be a negative exponent. We're going to move it one place to the right to get this into scientific notation. So this is going to be a negative 1. So we're looking 5.24 to the negative 1, and the correct answer is C. Okay. Now they've kind of deviated into quantities. This is pretty straightforward. It's important to choose an appropriate size of measurement. For example, is it more appropriate to represent the distance from California to New York as 2,441 miles as opposed to 1.55 times 10 to the 8th inches? Well, it would be ridiculous to measure the distance from California to New York in inches. So, of course, you would prefer to use miles there, and most of these are pretty obvious. The time it takes to travel from Florida to Michigan, well, minutes, it would be very hard to wrap your head around that, but hours is appropriate. The thickness of a penny, well, you're not going to measure that in meters. A meter is similar to a yard. That would be ridiculous. So it's millimeters. The length of a football field, I think most of us know we measure those in yards. And the weight of a paper clip is not going to be measured in pounds, but ounces. You can estimate very large or very small numbers by expressing them in the form of a single digit times an integer power of 10. Estimating very large or small numbers makes them easier to work with. Now, what they're talking about here is, yeah, this is a really long number, but notice it's not got a ton of zeros. And they're saying sometimes you want to make them zeros so that they're easier to wrap your head around. It wouldn't even be really worth changing this to scientific notation because they're not really going to shorten the number any. So they're saying sometimes what you need to do is estimate, and they're saying that this number here is approximately equal to 300 million. And then go ahead and take that number and write it in scientific notation. Now, we know the exponent will be positive because it's a large number, but how many times do we move the decimal from here to get it here? 1, 2, 3, 4, 5, 6, 7, 8 times. So that would be an 8. Okay. Here we have a very small number. We want the decimal to end up right here so that we have one non-zero number to the left of the decimal. How many places did we move it? 1, 2, 3, 4. So we're going to have 10, and because it's a small number, it's a negative 4. Okay. Choose units of appropriate size. If you could walk at a rate of 2 meters per second, it would take you 1.92 times 10 to the 8th seconds to walk to the moon. Is it more appropriate to report this time in seconds or years? Explain your reasoning. Well, of course, you're not going to describe how long it would take you to walk to the moon in seconds. That's an impossible number to comprehend. 6.9 years, well, you all know how long 6.9 years is. So the measure years is a more appropriate time. A plant cell has a diameter of 1.3 times 10 to the negative 8th kilometers. You're going to measure a plant cell in kilometers? Seriously? I don't think so. Millimeters is more appropriate. The population of Missouri is, now they want us to estimate this number, okay? Well, it's very close to 6 million, right? So they're saying, let's estimate it as 6 million. And, well, I guess we're supposed to write 6 million here. And then we will move the decimal. It starts here. We want it to end here. It moves 1, 2, 3, 4, 5, 6 places. Now we have to do it on our own. They're giving us, for the distance from the Earth to the Moon is this many miles. Now, there's some leeway here. I prefer to have one number to the left of the decimal and then at least one after the decimal. That's my preference. It's not necessary. You could have estimated this at 200,000 miles, but I think 2.4 is more accurate. And why did I choose 4? I rounded. I wanted one more number, and the 8 made the 3 round to a 4. Okay, that's why I chose that. How many times did I move the decimal? It ends here and it begins here. 1, 2, 3, 4, 5 places. And this is a large number, larger than 1. So this is a positive, positive 5. Okay. That's the end of today's video. I've started a new thing to make sure that kids are actually watching the video. I'm starting the secret word thing. On reveal, there is an assignment assigned to you. It has one question. And the question is, which of the following is the secret word? Well, the secret word for this video is Monday. You hear my dog barking. I'm filming this at home. The secret word for today is Monday. So go over to reveal, open that assignment, click the Monday option, and you will get 100 points for watching this video today. All right. Thanks for sticking around. Sorry about the dog barking. And I appreciate you watching the video. Have a good one.